All right, what's up everybody? Today we're going to be talking about exposed ports in Kubernetes, and I'm going to try to make this video under 10 minutes, but it's very difficult sometimes. But I wrote everything down in notes, so hopefully we can get through this pretty quickly. So we're talking about exposing your application to the outside world mainly, but we're going to start off with looking at something called ClusterIP. So in Kubernetes, you have ClusterIP and you have something called Node IP. Today we're looking at ClusterIP. This is not going to be a lesson on how to set up Kubernetes, how to use kubectl or how to use Minikube. I'm just specifically talking about ports and how they work. So you can come back to subsequent lessons and learn more about those individual topics. But today we're talking about ClusterIP, and the second part to this lesson we'll talk about Node IP. So let's get started. I'm going to follow my notes to my lab, which you guys can download from either GitHub or my website, Elliot Holden, my web guy. I'll leave a link in the description, but mainly it's going to be github.com/Elliot Holden/lessons. So that's ELLIOTHOLDEN/lessons on GitHub. Okay, so the first thing we're going to do is we're going to create a deployment. We're going to create a deployment called web with 3 replicas, and we're going to use the Nginx Docker image, okay? And specifically, we're not going to use the -- port flag. So let's see what we have already in our Minikube cluster. So kubectl get all. Okay, so we don't have any. All we have is the default service that comes set up with a Minikube default cluster. So we're going to create a deployment. We're going to say create. Well, actually, before we create the deployment, let me clear some things out of my directory. RM. Okay, so I'm in this KCNA directory. I've cleared it out. So we're going to create a deployment. Now, also in the instructions, I have to make sure to use the -- save config option. And we're also going to use a declarative form to create this deployment. So kubectl create deploy, and we're going to call it web. And like I said, we're going to use the Nginx image from Docker. We're going to create 3 replicas. Replicas equals 3. Now, here's the fun part. We're going to add the save config option equals true. And the reason we're doing this is because later when we rerun this deployment, we want to use the apply command to rerun our deployment. So having the -- save -config option set to true will allow us to do that. Okay, so we're going to say -o YAML, which is basically like saying -- output, but we're using the shorthand -o YAML. So we're going to output YAML. Then we're going to do a dry run. We're going to say -- dry run client. Now, what this is going to do is it's going to display the output to my screen. And made a typo. So output to my screen, if you guys notice here, this is, let me use my nice handy dandy annotation tool. So this is the output. Actually, start up at the top. This is the output, okay? And when we added the -- save config, it created this annotation right here, okay? All right, so now that this output is to the screen, we really want to save this in a file because we want to create this deployment in a declarative fashion, which means that we want to create a YAML file, but I wanted to display the output to my screen, and that's why we did -- dry run right here. So out -- dry run sent it out to our screen. Now what we're going to do is we're going to redirect this same output to a file called web.yaml. Okay. Now, as I told you before, when we ran this command, we did not use the -- port option. There's an option you can use with create deploy. I'm going to show you guys. Oops. Create deploy - help. So there's a -- port option, and we didn't use that, and I'm going to show you guys why. So here's our web.yaml file. Let's cat it out. Boom. Okay, same thing we saw on the screen before when we did the dry run to the screen. So the next step in our lab, what we're going to do is we're going to actually create the deployment. Because if we do kubectl get all we have is that one service. If we do kubectl get deploy, we don't have any deployments yet. So we're going to do kubectl create -f, and we're going to create the deployment. Everything I'm doing is in the lab, so you guys can follow the instructions in the lab and do everything that I'm doing right now. So we create the deployment, kubectl get all, and we see our pods got created right here, and we also see our deployment got created right here, okay? And we also see a replica set down here that got created. So everything went as planned. So now the next thing we're going to do is, since we created an Nginx deployment, my nose is itchy, I'm sorry. We want to make sure Nginx is actually running inside the pods or inside the containers that are in the pods or whatnot. And the easiest way for us to do that is we're going to do something called kubectl exec. This might remind you guys of Docker exec. So we're going to run a curl command inside the container just to see if Nginx is running. So how do we know what containers we need to use? We're going to do kubectl get pods. I'm sorry, let me back up. A better way to say this is we're running kubectl exec inside of a pod. Okay, not the container is in the pod, but kubectl works on pods. Docker, Podman, CRI/CTL, they work on containers, you know. Actually, Podman can work on pods too. But so anyway, we run kubectl get pods. We see our 3 pods that were created, and we're going to use one of those. We're going to say kubectl exec, and we're going to just use tab completion. So we use tab completion there, and unlike using Podman or Docker, you have to put this -- at the end of the container name before you actually type the command that you're going to use. So we're going to do curl -s localhost, and we see that we get the Nginx output. Now, mind you that when we do the localhost, when we added the localhost right here, we didn't put a port at the end because by default it uses port 80. But just to show you guys, to make sure we're all on the same page, just to show you that we are using port 80. See, port 80 right there. Hit enter, and there, we got it. So we know that something is running inside that pod container, as you will, over port 80, okay? So now what we're going to do is we're going to expose this web service, okay? So that we can use something called ClusterIP and we can access it. Now what ClusterIP means is that if you were to SSH into any one of the nodes in your cluster, you can access the service from any one of those nodes. You don't necessarily have to be pointing at a particular pod per se. So let me show you what I mean. So to create well, first we say kubectl get all. So we see the only service that we have right now is this default service. We're going to create a new service, okay? So we're going to say kubectl expose, because we're gonna expose this web deployment, this deployment called web, and that's how we create the service, is by exposing this web deployment. We could create a service without exposing. You can create a service on its own before you create a deployment, but we're just doing it this way for the purpose of this this lab. We created the deployment first, and now we're going to expose that deployment. So the deployment we're exposing is called web, and we're going to name our service web SVC. Okay, and we're going to hit enter, and we get an error message here. And the reason we're getting this error message, it says, oops, sorry, still learning how to work my annotation tool. Reason we're getting this error message that says can't find port via the dash dash port flag is because to create a service, you need to have a port, okay? Because that's going to be the service port that you're going to need to access that service, okay? So we don't have one. And looking at my instructions here, just so I can stay on task. Okay, so we did not define a port. And just to further reiterate on that, if we do kubectl describe deploy, if we describe the deployment called web, we will notice that right here in the port section, there's no port on that deployment. Okay, I don't know if I said service or deployment, but that deployment, there's no port. There needs to be a port that was assigned to that deployment if we're going to create a service without having the dash dash port flag. Because what happens is the port that was assigned in the deployment gets copied over to the service, and we'll take a look at that more. So again, if we do that describe command and we grep for ports or grep for port, you'll notice there's nothing. If we do kubectl describe pod, and which pod? Let's pick one. And we do the same thing, grep-i for port. You see we had no port. So what do we need to do to fix this issue? Well, right now what we're going to do is we're going to edit that file that we created, this web.yaml file. I'm going to cat it out for you guys again. We're going to edit this file, and we need to put something in this port section. And we don't really know. We could use the kubectl explain command and try to see what the correct syntax we need to put for the port. But instead of doing that, we're just going to rerun. We're going to rerun our deployment command, and we're going to come back over here and we're going to add dash dash port equals 7480. This is just a port I'm making up, off the top of my head. It's also in the lab. And I'm going to show you what happens when we do that. When we do that, if you guys notice down here, it's going to create a little port section that says 7480. Okay? So that's going to be our service port. So what we're going to do right now is we are going to pipe that again into... Now again, we could do one of two things. We can pipe this into not pipe, but we can redirect this and overwrite our previous YAML file, or we could, another option to doing this, kind of scroll back. Okay, another option to doing this is when we added that, this dash dash port 7480, we could just grab this, copy this out right here, and we could just edit. We could edit this file, I'm just showing you different ways we could solve this problem. We could edit this file and come in here and put that in there like that. We could do that, or I'm not going to save this change right now. We could also do kubectl edit or deploy or edit deploy. We could edit our deployment called web. Edit deploy web. And we could come down here and we could copy it and paste it in. But instead, that's kind of messy to be doing all this right here. You know, we could put it in here, something like that. But we're not going to do that. We're not going to save that either. All we're going to do is we're going to overwrite that file web.yaml. So now if I cat out the web.yaml, you guys see we have that new port section in that file. And now what we're going to do is we're going to use the kubectl apply command. Now if we didn't do the -- save config when we first created this deployment, we wouldn't be able to use apply on it to update it. So, and I want to show you a couple more things. Actually, before we do the apply real quick, I'm going to do kubectl get pods. These pods are going to get updated because we're really rerunning the deployment. We're recreating the deployment. Okay, so I just kind of wanted to point that out. So let's just do this. Make it a little bit more cleaner for you guys. Okay. All right. So we say kubectl apply -f web.yaml. Okay, so we just ran that deployment again, and let's see. So you notice it's terminating the old pods and it's creating new pods. So notice these pod names are now different. Okay, every time you rerun the deployment, you're going to get different pod names. Okay, all right. So, and also, so we're kind of learning different concepts here. The video would be much longer if I did not have it all written down and annotated. So now what we're going to do is we're going to say kubectl describe. We're going to run that describe again, describe pod. And which one are we going to do? Let's pick this one. And we're going to grep for -i port. And now you notice we do have something in the port section. And same thing if we say kubectl describe deploy web, and we grep -i for port. Oops. Okay, and again we have something right here in this port section. Now, what's the purpose? Oh, what's the purpose of having that there? Well, now we can create our service that we could not create before. And the way we created our service before was we did not use the -- port option. So I'm doing this to show you that when you don't use the -- port option when creating a service, it's going to copy the port that's in the deployment. That's the whole point of me showing you this. So kubectl expose. kubectl expose. We want to expose that that deployment. Deploy web, and we're going to call this web svc. Remember, the first time we got an error message when we did this because we're not using the -- port option, and it's going to copy the port that we used in the deployment. Okay, so now we do kubectl get svc. svc is just short for service. kubectl get service. Okay. All right. So now we have this thing called a cluster IP down here. So here's our service. We have a cluster IP, and we also have, there's the port that got copied over, okay? So how can we use this? Well, we need to SSH into one of the nodes, any which node, and if we SSH into one of the nodes, we should be then able to access the service using that port number. It's not going to work. I'm going to show you guys why, but let's just go down this rabbit hole. So kubectl, let's do get nodes. Okay. So these are my nodes. Another way to get the nodes is kubectl get pods -o for wide, and we also see the nodes over here. Okay. And here's the nodes from the first command. So how do we SSH into them? I'm using Minikube. So since I'm using Minikube, we're going to say Minikube SSH -n for node. And let's just use DevOps -m03. Okay? Oops. DevOps. Okay. So now that we're actually on one of the nodes, and we can do host name to show that we are on one of the nodes. Okay, we're on the DevOps 03 node. Right here's where it says it. Okay, so the next thing I'm going to clear up some of my annotations in a second. But the next thing we're going to do is we're going to use this cluster IP up here. Remember the cluster IP? And we're going to try to access the service. So how do we do it? Well, we're on one of the nodes, and I told you that we can use that cluster IP. We can curl to it. Copy it. Sorry. Miskeyed something. Command C. So curl 7480. So technically this should show us something if we were able to access it. And it says there's an error, so failed to connect to that port. Okay? But I also want to show you at this time that that service is still actually running. Okay? We can actually use the Docker command right now. Since we're actually on the node, we're not going to use kubectl because kubectl is when we're accessing pods. Right now, we want to access the actual container. Okay, so what we're going to do is we're going to come back and grab. Let's see. So if you look at right here, we're going to use that node. I mean that container, because it goes to, well, let's just do this. Let me do it a little bit cleaner so you guys can see. See this right here? See, we're going to, that's the pod name, but we need the container name. So we're going to do Docker PS grep for this particular, why are we using this particular pod name to grep? Because this pod is actually on the DevOps 03 node, which is what we are actually on right now. So you see the container name is, the container ID is right here. Okay. So what we want to do is we want to grab this container ID and we want to say Docker, Docker exec. And what are we going to do? We don't need this we don't need the --. We only need that when we're actually using the kubectl to do kubectl exec. So from here, we are going to run a curl command, localhost, which is going over port 80. And we should see that Nginx information, because I just want to show you that the service is still actually running. Let me clear this stuff out. As you guys see, we got good output right here. We got this HTML. Okay, server's still running. We just can't get to it from the cluster IP, and but the service is still there. So we're gonna come out of here. We're gonna exit out of the node. Okay, get back to our host machine because right now we're on the node. We're on DevOps MO3. Exit out. Back on my host system. Again, if I ran kubectl get pods, and I just grabbed any one of these pods and did kubectl exec, you can see that the actual service, let's see what I did wrong. Kubectl is not supported anymore. Oh, I forgot to put that dash dash at the end of there. So, why isn't it working with our service? That is the question. Okay, I think my camera wants to stop on me. I'm not sure. Let me stop it and start it again. Okay, sorry, I had to restart my camera. So let's take a look. kubectl get all. Okay, we do kubectl get all, and we see our service up here, and we also see our deployment. Here's our service. Here's our deployment. Okay, let's actually examine the service though. We want to examine this right here. So we're going to do kubectl describe service. We can just say SVC is short for service. And which service do we want? The web SVC. So when we describe it, I want you guys to look down here to where it says target port. Okay, this is why it's not working, because you see this line right here? These are all the IP addresses. These are all the IP addresses of the different containers, or pods rather, and you see it wants to go to 7480. That's the target IP. That target IP is incorrect. So to fix this, we can actually just edit the web service. Okay. So if we do kubectl edit, edit service web SVC, and we come down here to the target port area. And remember, we don't need to worry about the port. We need to worry about the target port, because that's signifying what the service is actually running on inside the container, or inside the pod rather. So we save it. And now when we do a describe on it, we notice that all those target ports have changed. So now it should still work. We should still be able to use our node IP with that particular port, and we should be able, it doesn't matter which node we're on, we should be able to still access the service using our cluster IP. Okay, I don't know if I said node IP, I meant to say cluster IP. So let's take a look. So let's say kubectl get nodes. Okay, and kubectl get SVC. Okay, because we need this node IP. I'm going to go ahead and save it right now. So kubectl minikube SSH, and we're going to go into, let's just pick one at random. Let's pick the DevOps node, which is our control plane node, as you guys see right here. The DevOps node is our control plane node. So we're going to go into our control plane node and type hostname. You can see we're on that node. And now we're going to run the curl command to that port 7480. Let me do something real quick. Set this VI. Okay, let's try it again. 7480. And you guys see that it works, okay? And just to prove a point, we're going to go into one of these other nodes. Let's go into MO2 and MO3. See these two up here? We're going to SSH into those and make sure that it works. So we're going to SSH to DevOps-MO2. And I'm going to say curl 7480. That works. And let's SSH into MO3. And just to show you that it works on all of them, curl-s 7480. Okay? So now you see that that's the purpose of ClusterIP. ClusterIP allows you to access the application or your service on any node on the cluster using that ClusterIP and that port. Now, there's some other notes that I made that I might need to talk about a little bit. Okay. One thing is, we're going to back up a little bit. When we were testing actually on the cluster, let's actually go back to one of the nodes. Let's go to MO2, okay? When we wanted to test the application, remember, we ran Docker PS. Actually, let me get one of the, Docker PS. And we'll just use this first one I know is the container image that we want. So we saw how to test it using this Docker exec curl localhost. So that works. But what if we try to use telnet to test it? So let's use telnet. Telnet localhost port 80. So we get an error message, and the error is telling us executable telnet, that file is not found. Telnet is not installed inside the container. I'm going to show you guys a troubleshooting technique that you can use to run commands that are installed on your host, on your node, but not actually in the container. You can use those against your containers, okay? And the reason you can do that is because the container is just a process that's running. It has a process ID that's running on top on the node. So what am I saying? I'm saying that because I can't run that telnet command inside of there, I can run it using something called nsenter, okay? So if we do nsenter and we give it the process ID, which we don't know the process ID yet, I'm going to show you how to find that. If we run nsenter command, we'll be able to do what we want to do. So let me show you how to get the process ID. You can do it one of a couple ways. You can say docker inspect. You can inspect the container, and then you can do -- format state.pid. This is the process ID that's running inside of it, okay? I did a little fancy format thing right here. You guys can look into that later, but even if you didn't know to do that, you could just grep for PID. And what is this doing? Again, it's returning the process, the Nginx process as it appears to the host system. When I say host, I mean the node that the container is running on, or the pod is running on our cluster. So this particular node. So that's the process ID. Another way to get that process ID is to run docker top, and you see that same process ID right there, okay? Another way to get that process ID, if you didn't know it, what's the other way? Oh, we could do, you could do the regular PS command on the node, and you could grep for Nginx, and you see it again. You see the, and it says master process. That's how you know. You know, same right here. You see, you know it's the right process because you see master process. Okay? So, and then you can got that process ID. So there's different ways you can get that process ID, which is 118.968. Okay? So once you have that process ID, what you do is you run ns enter. Remember, we need that process ID to run ns enter. Sudo ns enter -t, and here's the process ID. And what's the what is the command that we want to run inside? Well, we want to run the telnet command, telnet localhost. This is the command we're running inside of the container. And it says connected to localhost, so you know that it works. Let me show you another command that you could use. Get out of here. There's a command called a SS command. So same thing. If we ran docker exec and we tried to run the SS command, it says again, that command is not in the container. So what can we do? Well, same way we ran this, we can run that SS command. The SS command is installed on our node. And look at there. We're verifying that there's a process running inside the container off that port. So hopefully you're getting a lot of good, knowledge out of this. I know we're deviating a little bit here and there, but I'm showing you tips and tricks for troubleshooting, ways that you can verify that a process is actually running in that container or pod. You can use kubectl to exec into the pod, or you can SSH into the node, and you can use docker command. You can also use cryctl command, kind of going deep here. You can use this command and again, it's running just like you would be running the docker command. The cryctl is like a lower level. I don't quite know how to explain it. I'll let you guys look that up. But essentially you can use it like Docker or Podman when you're running a Kubernetes system, Kubernetes environment. So if we do curl localhost, because we know that curl is running inside that, and we get the same thing. So we looked at how to deploy or how to expose a service. kubectl get all. Now, when we created our service, we could have used --target port, and that would have saved us not having to edit the service. Yeah, but we didn't do that. I wanted to take you guys around the long way so you kind of see how everything works. Now, here's another concept. We can have multiple kubectl get service. We can have multiple services that are all, pointing to the same thing, right? Because this combination of IP address and port is what makes what we call a socket, and that is a unique combination. What am I trying to say? I'm trying to say that if we run kubectl expose, we're going to expose that web service again. I mean, a deployment, expose deploy web. We're going to create another service. we're going to create something called Web SVC 2. We're going to create another one. But this time, we're going to say, we're going to do two things. We're going to say -- port, because I'm going to show you guys something that's very cool here. We're just going to make something up. We're going to say 9480 or 9280, okay? And the target port, remember, the target port needs to be the actual port that the process on the container is running on. So you need to get that correct. So target port, we're going to say 80. So why am I doing this? I'm going to show you. Target port. So the reason I'm doing this, kubectl, get SVC. I'm showing you guys that we have actually two services now. Okay? Now, both of these services, technically, since it's all on the same cluster, the ClusterIP should be able to access the different services. Why? Because we expose the deploy. Okay? So when we expose the deploy, if we come back over here to the deploy and we say kubectl describe deploy web, we still have 7480, but I'm going to show you guys that that doesn't really mean much. Okay? That doesn't really mean anything. I know it sounds weird. See, check it out. kubectl get pod grep-i port. Oops. I said get pods. We need to describe pod. Describe. Okay. And describe deploy. I'm doing all this just to prove a point, guys. Okay? So I hope you're not getting bored, because I'm trying to prove a point here. Okay? So the deployment and the pod both have that particular port number. Terrible at this annotation stuff. See? There. There. But our new service has this. So let's play. Actually, I don't know if this is going to work, but I'm just guessing as I'm going along that this is probably how this all works. So kubectl get nodes. And let's go inside one of the nodes. So minikube SSH-in DevOps. And then we're going to say, curl-s, and we're going to use this new IP address right here. Because remember, this is still forwarding, should be forwarding, 9280 is forwarding to port 80 in our cluster. So, and it works. So, you know, my assumption here is that now what would happen if you tried to create another? Could you run another deployment with another web server? How would you know which one you're accessing? I don't know. That's a good. Let's try something. What if we did a new deployment? kubectl